Alright, problem number 5. In a carnival game, round discs are tossed onto a 32-inch by 32-inch table top covered with a checkerboard made up of 4-inch by 4-inch red and black squares. The discs have a radius of 1 inch. If a disc lands completely within a red square, you win a prize. And it says no part of the disc can touch a black square or hang over the edge of the table. It has to be completely within the red square. What is the probability of winning if the disc lands on the table without falling off? Alright, well, you can see this is 32 inches by 32 inches, and each of the squares is 4 inches by 4 inches. So we've got 8 squares across, so 8 times 4 is 32, so everything works out. So the table is completely covered with these 4 by 4 inch squares. And so we've got 8 rows and 4 red squares in each row. Right, so we have a total of 32 red squares. Okay, so let's zoom in on one of those red squares and figure out what where this disc has to land in order to win. Okay, because it can't land anywhere within that 4 by 4 inch square. It's got the edges of the disc have to be completely within the red square. So I'm going to draw a little bit bigger red square here for us to help us see it. Alright, so I'm going to draw a square. Alright, I think that's pretty square, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Alright, so there's a square. And I'll color it red. So I'll use a highlighter here and color red so we know we're dealing with this red square. Alright. So where does this thing have to land? We have discs that are 1 inch in radius. Okay, so radius, don't get confused. So that means it's 2 inches in diameter. And this is 4 inches by 4 inches, right? 4 by 4. Okay, so essentially when the disc lands within the red square, okay, it's about half the size. The diameter is will go out to about half. So let me just sketch in what this disc would look like at one of its extremes, actually. Well, okay, so there's one of the discs. All right, and it has 1 inch diameter. All right, so it's so in order to land completely within a red square, the center of the disc has to be at least 1 inch from the edges of this red square. Okay, so let's focus in on that center. It makes it a little bit easier to deal with. So if I kind of draw in where the center could land and still be within the red square. So the whole disc is within the red square. Let's look at just where the center could land. So, it could land there, it could land, my lines aren't straight, but so as long as the center is within 1 inch of the edge, okay, in any direction, let's see, 1 inch, so this distance is 1 inch, 1 inch, okay, then the whole disc will be within the red square, okay? So essentially, the valid area for the center to land is in this middle area here. Okay, so how big is that? So we're 1 inch from this edge, 1 inch for this edge, so this is 2 inches across here, okay, or 2 inches this way. So it's a 2 by 2 square in the middle of the red square where the center could land and have the disc totally within the red square. Okay, so that's the area that we're looking at. That's where it can land, where the center could land, and we win the prize. All right, so the area is 2 by 2 or 4 square inches times, and how many? So we had 32 red squares. So 32 red squares. So that would give us the area, the valid area where it could land. All these little squares in the middle of each one of these where the center could land and we would win a prize. Okay? And then let's compare that to the total area where it could land. Okay, so as long as the center, we're going to assume that these disks are sort of a uniform mass all the way across. So the center of gravity is in the center of the disk. Okay, so as long as the center of gravity is on the table, it won't fall off. Okay, if we have a disk that lands like this, and the center of gravity is out here beyond the edge of the table, it's going to fall off, right? So let's look at the valid area where it can land and not fall off. Well, that's just going to be 32 by 32, right? So this is the total area where it could land and not fall off. And then we can just compare those two areas. So we have 32 by 32 is a total possible area where the center could land, and the area on the table where the center could land and we win a prize is 4 times 32. Okay, so that's going to be our probability. I could write P equals. Alright, and let's see, if we 32 over 32 is just 1, and then I can divide 4 into 32 and I get 8, right? So that's equal to 1/8. So we have a 1/8 chance of winning the prize if the disc does not fall off the table. Okay, and that's equal to 12.5%. Okay, so there you go. There's the answer, 1/8.